I want to show you a few ways to take control of your devices and rely less on someone else's servers. Cloud-reliant home automation is putting your home's infrastructure and data in the hands of someone that isn't you, a company. Whether that company is secure or at least not malicious is a gamble as it is, but I don't want to give them that power over my home anyway, and neither should you. I don't like being told how and when I can use my light switches. I don't like relying on services provided by companies that may or may not get bored of their product or intentionally deprecate it in order to force me to spend more money. I don't like devices that stop working, not because they've failed in any physical way, but because they can't reach some cloud service or because some subscription has lapsed. In addition to brand-specific mobile apps, a lot of devices rely on public cloud services like weather data, time and date information, or news feeds. Some devices will lose some or all functionality without these services. Here's the thing. You can provide most of those services to your devices yourself, and without spending a ton of money on a rack or pursuing a degree in computer science. I'm going to show you how after a brief talk about hardware. Now, I did spend some money on a rack, and I do have a computer science degree, but my most critical servers aren't on my rack. Most of the servers I have ever had have just been Linux on older hardware. It's a lot cheaper and oftentimes more power efficient and performant for my needs. If you're worried about aged drives failing, have a reliable NAS RAID or the like and back up crucial data and configurations yourself. Cost, performance, and power savings aren't the only reasons to use older or alternative hardware. This is a Dell Rugged 6420 XFR. It hosts my Ubiquiti network controller and a live backup of my Home Assistant, which I'll cover in a completely different video. This is a Dell 2714 mil-spec 2-in-1. I'll be using it to demonstrate everything I'm talking about in just a few moments. I can't say using these specific machines would be cheap. I paid a little over $600 for this one and a little under $600 for this one. I have a ThinkCenter running my live DNS and a few other things on Docker pretty smoothly, and you can probably find one of these for as little as $150. I got mine for $75 when the company I was working for at the time decided to replace them. But you may find that spending the extra money on a laptop is worth it for the same reasons I do. Laptops more or less have their own uninterruptible power supply and use much less power than something like my Dell PowerEdge. Provided the battery is in good condition, you could get several hours of uptime for backing up and/or safely shutting down in a power outage. Another reason I bought these specific laptops is that they're practically indestructible. I don't expect this to be necessary, but I always think what might happen if a neighboring tree were to land on a section of my house or the like. While these wouldn't survive having a tree fall directly on them, they absolutely have a high chance of surviving debris falling on them, being drenched with heavy rain, or falling from a pretty significant height. Really, most of what I'm going to cover will run on pretty old or weak machines with little trouble, like the ThinkCenter. But I recommend having at least a little muscle in case you run something heavy or run a lot of little things. Okay, I'll stop babbling about the hardware and get into the good stuff. If you want me to cover hardware in more detail and talk about things like CPUs, architectures, memory, or what have you, let me know in the usual way. Smoke signals. If you don't live on top of a large hill or your lease agreement forbids setting fires on the roof, you could also use the comment section of this video. While I'm talking about that, I might as well implore you to indicate to the all-seeing algorithm that I'm fairly neato by clicking the icon of a popular multicultural symbol of approval often found on the bit towards the end of your arm. I would guess a significant number of my viewers probably already know what Docker is. Some might even have more knowledge about it than I do. But that's one thing that makes Docker great. You don't need to be an IT professional to use it. So for those who aren't familiar, a summarized explanation would be that Docker allows you to create little virtual containers that make it easy to deploy, replace, back up, or otherwise manipulate servers. There are multiple ways to run Docker. You can run it on a Windows machine natively, or through a Linux subsystem if you like. Or you can run it on a Linux server on an ARM system like a Raspberry Pi, or just a regular PC. For the purposes of this video, I'm actually wiping this machine and starting from scratch so you can see what's involved from plugging in a machine for the first time to having all the services you want or need. I'm going to install the server OS, set up Docker, and show you how to get and deploy containers for Portainer, NTP, DNS and DHCP, AdGuard, FileBrowser, an Nginx web server and proxy, Kiwix local wikis, and a customizable Python Flask API. I'll be using command line, but I'm also going to show you how to install and use a container manager called Portainer, which I use regularly. There may be better container managers or ones that are preferred for certain situations, but I have had no trouble at all with Portainer. I really like it. Okay, let's begin. I'm going to install Ubuntu Server 24.04 long-term support using a USB drive. You can create one of these with a variety of tools, but I usually use the Raspberry Pi Imager or Rufus. I'll link to the instructions for those in the description. Just to show you how smooth and quick the Ubuntu installation process is, I'm going to time from opening the laptop to getting a login screen. I may speed the footage itself up to save time, but the timer will stay true to the video's real time. When the machine boots, since it's a Dell, I can just spam the F12 key a bit to get the boot menu. This procedure can vary with hardware, so you may need to look into the process for whatever you're using. I also recommend setting the boot order in BIOS such that any external drive or media is used before the internal drive, if you know how. That way you can do something if you have a laptop with a suddenly dead screen or the like. This is generally considered a security risk in large organizations, but I think if someone has physical access to my server hardware, I've probably got bigger problems to worry about. Once I boot from the USB, I'm faced with the server installer. I'll choose my language and continue to keyboard selection. The default is fine, so I'll move on. I always check for third-party drivers because I like using all of my hardware. Now it wants a network connection. Select the Wi-Fi adapter, edit Wi-Fi, and put in the Wi-Fi credentials. I could have just plugged it into a switch with an Ethernet cable, but I decided to just connect it over Wi-Fi because I'm too lazy to look for a network cable. Once it's got an IP address, I'll continue to the next step. No proxy address is needed, so I'll continue again. It'll take a moment to check that it can reach the package mirrors. There's a notification that there is a new version of the installer. I always upgrade before continuing because it's a really good idea from a security and reliability standpoint. It'll take just a few moments to download and initialize the updated installer. Once it's done, the installer will ask you if you want to use the entire volume. Leave it default to wipe the drive unless you have some special setup in mind, which you'll have to research elsewhere as I'm not covering advanced partitioning or the like in this video. Lastly, the installer will present a summary of the install. Continuing on, it will double check that I'm serious about the hard drive situation, which I am, and then it will ask for user and hostname information. It asks if I want to enable Ubuntu Pro, which I'm leaving off for now. I may enable it on a couple of machines. You get 3 free for personal use, so you can get security updates, but I haven't used it yet. I'm going to install OpenSSH because I want to access the machine remotely. Now I can select some services that I can install by default. There are quite a few useful things here, but as I'm planning to containerize all of my services, I'm only going to need one of these: Docker. I want to point out to the more advanced Linux users that selecting Docker here installs the snap version. This is more secure and suitable for most things, but some things, like Chasm, don't play well with the restricted nature of the snap version. So, if you plan to use something like that, you may want to look up installing Docker the old-fashioned way through the package manager or a bash script. Okay, now it'll take a few minutes to install, and then I reboot, and eventually, I'm at the login screen. 8 minutes and 23 seconds from opening the laptop to having a Docker server. Oh, these magical, maniacal modern times. As I mentioned earlier, I like to use a Docker manager called Portainer for a lot of what I do on my Docker servers. It's light and extremely useful. Creating and starting a Portainer container is pretty easy. Logged into the server via Secure Shell, you can run this command, which I'll list in the description, and you'll have Portainer. Now, just navigate to the port's IP address at port 9443, and voila, there it is, Portainer. Set the admin login info and go ahead and attach to the local server. That's it. Now you can do all kinds of things, from monitoring to creating containers or custom templates, which we will be doing a bit of in this video. The service that made me decide to do this video is actually NTP, the Network Time Protocol. This is basically just a service that devices check in with to make sure they have the correct time, from time to time. This is a pretty simple service and a pretty simple creation process as well. Simply paste the contents of a file included in the description into the Docker Compose YAML file in a folder designated for this purpose.
Editor Ian here, and I'm going to make a correction. I thought that I was doing this in command line for some reason, and I'm not. So the actual instructions are to go to the custom templates in the Portainer and create a new custom template. Name it whatever you want. It has to have a description, and then you can paste the same contents you would into the regular Docker Compose YAML into the web editor below, and then you can deploy it.
Now you can go into devices like this Shelly RGB WPM and set the NTP address so you don't need the internet for your devices to have the correct time. Let's move on to another common service that will make your life a lot better. DNS, the Domain Name Service. One of the most useful services I think you can have is DNS. This is for a few reasons, the two most important being that it's easier to remember light1.kitchen.house than it is to remember every device's IP address. And if your ISP's DNS became unavailable, but you still had internet connectivity, you can still resolve addresses that are cached in your DNS server. You can even set some static records for really important things. I am going to simply supply you with a compose file for this one, and I'm going to use command line to create the container. I ran into a couple things this time that I somehow didn't in my previous server install, but what it boils down to is this. You'll need to turn off the local resolver on the host if you get an error when you run compose that looks like this. I'll put the commands for this in the description. Okay. Now that Technitium, not sure how it's pronounced, is running, let's go ahead and do some configuration. I'll set the admin password, then go to zones. I'm going to add a zone called lab.local. You can make this whatever you want, but I'd avoid things that are actually out there because you could have issues later. Before I add a record to the new zone, I'm going to install a super useful app called Split Horizon. A split horizon record is one that can resolve an address differently depending on the network the request is coming from. This is very useful for services that you want to access locally and over the internet. Under the Apps tab, open the App Store and find Split Horizon. Now it's time to configure the app. I would definitely check the documentation on how to use this config file, but for this setup, I'll just create some mock network info on top of the real network I'm using. Now I'll go back and I'll add a record for the Shelly RGB WPM in the studio. After I flush cache, I can navigate to the address of record, and there's the RGB WPM. Having a DNS server is great, but there's one thing you can add to your service collection to make it even better. AdGuard. To create an AdGuard container, I've altered the command found on the AdGuard site, link in the description, to fit my setup. If you're going to have a DNS server on the same machine, you'll need to change the port. I'm just making it 553 instead of 53. I'm using my DNS server to both be a lookup for outside queries and, more importantly, to make managing my network and devices easier. But I still want AdGuard, which is also technically a DNS server. So to use both, I need to set up a forward lookup manually so that the Technitium server asks the AdGuard server exclusively for information it doesn't have. After the container starts, I'll navigate to the IP of the server at port 3000. There's an initial setup process that can be quite involved, but I'll keep it pretty basic here. The first information it will want from you is the interface IP information. This can be left as is. Next, set the admin username and password. I'm just going to use admin. I'm not going to be keeping this particular service because I already have it on another machine. Now it'll give you some information on directing devices to this server. Ignore that if you're using Technetium, because the Technetium server will be the only thing pointed to AdGuard. Everything else will be pointed to Technetium. And that's it. Now you have AdGuard. If you are using Technetium, log into it and go to Settings, Proxy and Forwarders, and add the IP of the machine at port 553, then save that and you're good to go. Now, I want to show you one neat application I've been using that allows you to access a file store through the browser. It's not quite as complex or feature-heavy as something like Paperless or Nextcloud. It's called FileBrowser. Simple and to the point. This is also a good time to use templates in Portainer. I have used many of the predefined templates and never had any complaints. Just select FileBrowser from the application templates and start configuring. You can give the container a name or let Docker give it a random one. I want to keep the files and configuration in subdirectories of my home folder, or wherever, so I set up the bindings here. One for the data folder, which is where the database for configuration and indexing lives, and one for the actual files, so you can access them outside of the container on the host machine. Now just set the port, which I'll show you how to proxy to a bit later. Okay, I'm going to go ahead and create the folders I need through Secure Shell. Finally, deploy the container. After it's done deploying, navigate to the host IP address and the port that was set, and there it is. The default login is admin. Once you're in, you can go to Settings, User Management, and set the password. Here, I'm adding a directory just to illustrate the relationship between the host folder and the container. Now, let's say I want to access this site remotely, or even just by typing in a URL with no port. In order to do that, we'll need a proxy. Generally, a proxy is a pass-through for traffic, a gateway of sorts. The easiest way to do this, for me, is Nginx. Nginx is a lightweight web server, so it accepts HTTP and HTTPS requests. This gives us a way to not only filter all traffic through a closer controlled environment, but it also gives us a way to set up SSL certificates, something I'll actually cover in a different video. Of course, if you have questions, please feel free to ask. I may answer in the reply, or perhaps even on the Friday podcast. Oh yeah, there's a Friday podcast in case you didn't notice that before. Let me know in the comments what you think or if you plan to listen. Also, if you are so inclined and enjoying the video and or maybe even learning a thing or two, you might help support the channel by leaving a like. I know this gets said over and over, but it is free and it is the most effective thing you can do to support the channel besides watching the video. I'd really like to keep doing this thing with you folks. Okay, back to setting up our Nginx proxy. I'm going to lean on Portainer again here because why not? The templates that are available, if they fill the need at the time, are great tools to have on hand. So, go to the application templates, scroll a little way, and click on Nginx. I'll put in a container name, and I'm switching the network type to host here, which basically just means that the container will access the network interface at the host level. In other words, whatever the host sees, the container sees. Now I'm going to create a couple folders for config files and web page files if I want to make a site on the server for some reason. I wouldn't serve an API from this container. I will show you how to make a Python Flask API container a little later. The container is going to expect at least an nginx.config file, a MIME types file, and a default site config if you reference one in the Nginx config, which I usually do for separation of concerns. I will leave links to all of these files and list all commands used in this video in the description. I may put up a custom page somewhere with reference to all of the stuff I've covered here. In any case, check the description for more information. I'm simply copying reference files from Github as well as my other servers. You can simply download the ones I make available, change what needs to be changed to use it in your network, and you should be good to go. Okay, DNS time. I'm adding a simple A record here because I'm not fiddling with the split horizon record right now. Once I have that record saved, I can flush my DNS cache and navigate to files.lab.local, and there we are, the file browser. The next item isn't as important as the others for smooth smart homes, but it may be a good idea for anyone who might want to look up information even if their internet is down. It's called Kiwix, and it's an open source project that creates offline copies of sites like Wikipedia and WikiHow. Of course, you need a bit of space, but it's not as bad as you might think. The full Wikipedia image is only just over 100 gig. Fortunately, all you need to do to create the container is run a command, which will be in the description, of course. When I first ran it, I got an error starting because I didn't have the zim files in place. The container was there and perfectly fine, but I had to come back later after at least one zim file was copied over and restart the container. After that, I navigated to the server's IP at the appropriate port, and there it is. A wiki clone that's offline and locally accessible. There is one last container I want to install. I want to create a container that serves an API for custom automations. I will supply the compose file in the description. It will bind to a folder on the host where you can modify the source code as needed, and all you need to do is restart the container after you've saved changes. Portainer is particularly helpful when doing things like this because you can monitor the log for the container without even secure shelling in. I'll provide the code for this little demo API as well. Perhaps in another video I'll cover my Discord bot that monitors an API like this one from a small cloud server and sends me direct messages if it goes offline or comes back. Okay, before I close, I want to thank my members, shown here and here. And to everyone watching, I sincerely thank you for being here. We don't know our total supply of minutes. You gave me some of yours, and I want you to know that I genuinely appreciate that. I do hope you'll join me for future videos as I continue exploring smarter circuits.